Let's have a look at the common connectors on a motherboard. Shown here are the connectors that are covered in this video and the timecode where they are talked about. If you are only interested in a particular connector, you can go to the timecode shown. In this video, we will cover content relevant to the A+ exam, although a lot of the material is also presented in other videos within the course. If you're solely preparing for the exam, feel free to bypass this video. This particular video is tailored for individuals aiming to master the art of assembling a computer and gain a comprehensive understanding of the typical connectors on a motherboard. A good starting point to gain a grasp of your motherboard's capabilities and to locate its connections is by looking at the motherboard diagram provided in the manual. The diagram will tell you where all the connectors are on the motherboard. Sometimes it can be hard to find the connectors on the motherboard. Some look very similar, while others may be difficult to see. The power supply unit, or PSU, comes in three main types. These are fully modular, semi-modular, and non-modular or fixed. Modularity in a power supply indicates how many of the cables can be connected or disconnected, as opposed to being permanently fixed. Non-modular will have none. Semi-modular will generally have the main motherboard connectors fixed and cables for peripherals detachable, while with fully modular, all cables can be attached or detached. The power supplies work the same way. The main difference is that the more modular the power supply is, generally the higher its price, although the price jump is generally not that high. Shown here is a fully modular power supply. You can see all the connectors are detachable and not fixed to the power supply. To connect one, it is just a matter of pushing the connector into the correct plug on the power supply. The power supply connectors have unique keying to prevent incorrect insertions. However, there isn't a universal standard across different power supplies. Consequently, while cables from one power supply might physically fit another, their wiring configurations can differ. This mismatch can lead to the wrong voltages being transmitted, risking damage to computer components. This can even occur with power supplies from the same manufacturer, so don't use cables from different power supplies unless you can be sure they are wired the same way. I will now have a look at how the cables plug into the motherboard. The main power connector to the motherboard, also known as the P1 connector, is a 24-pin connector. It was added in the ATX 12V 2.0 revision. For any ATX system, the ATX 12V standard will be used. There have been a number of revisions over the years to this standard. The revisions are mainly improvements for tighter control of power supplies and for additional connectors. However, connectors have remained compatible with older revisions. Before this standard, there was a 20-pin connector. As computers started using more power, the 24-pin connector was also unable to provide the power required. Thus, in 2003, the standard was changed so the connector had 24 pins. Manufacturers were quick to start using this standard. Thus, nowadays, unless you are working on a very old computer, you are unlikely to come across the older versions. To help remain compatible with older versions, the power supply may have the last 4 pins detachable from the connector. Thus, if you are plugging into an old computer, you can detach these extra 4 pins. These connectors may be referred to as 20 plus 4 pin connectors. Since 20-pin motherboards are so old now, a lot of power supply manufacturers are no longer providing the 24-pin connector where you can split the last 4 pins. If this is the case, you can always plug the 24-pin connector in, and the extra pins will just hang outside the connector. The first step to plugging in the P1 connector is to first locate it on the motherboard. In the case of this motherboard, the ATX plug is near the memory modules, which is a fairly common place for it. However, the manufacturer of the motherboard is free to put it anywhere they wish. I will plug this P1 connector into the motherboard. Notice that this particular connector does not have the ability to split the last 4 pins, which is becoming more common nowadays. It is just a matter of plugging the cable into the motherboard. Notice that on the connector there is a plastic hook, and the plug has a protrusion. This prevents the connector from being plugged in the wrong way. It is now just a matter of pushing the connector in and you should hear a click. The connector is keyed so that it will only go in one way. If you are having trouble getting the connector to plug into the motherboard, you may have it around the wrong way. If you look at the connector, you will see that there are two types of pins: square pins and square pins with a bevel on the edge. These may be a bit difficult to tell apart at first, but once you start looking at a few cables, it gets easier. You will find that all the power cables from the PSU use this method of keying. It is possible to force a connector into the plug the incorrect way. If you do this, there is a very good chance that you will damage your motherboard if you switch the power on. If you are finding that the connector won't plug in, check the keying to make sure it is correct. If you can't tell, try it the other way. As CPUs started to use more power, the P1 connector became insufficient and additional power connectors were required. In order to provide additional power to the computer, a 4-pin power connector was added. The formal name was the Plus 12 power connector, or ATX12V. It was first added to provide additional power for the Pentium 4 processor. Thus, it was informally called the P4 connector. This connector provides two additional 12-volt wires to the motherboard. Let's have a look at how to plug it in. To start with, I will have a look at an older motherboard. The P4 connection provided additional power to the motherboard, but as time passed, it disappeared and was replaced with the next connector I will look at. However, as we will see shortly, the P4 connector is returning on some newer motherboards. On this motherboard, the P4 plug is near the edge close to the CPU. The motherboard manufacturer can place this plug anywhere they want, however, it is generally found in this area. You generally don't find it close to the P1 connector because, if you think about it from an engineering point of view, if you already have a large connector like the P1 connector providing power, why would you put another power plug in the same place? It would be like putting all your power outlets in your house in the same location. You want to spread them around so that they can be used in different areas. In this case, different areas of the motherboard. The plug can be a little difficult to find since it is small, and things like CPU coolers, cables, and other components can make it difficult. Once you find it, just like the P1 connector, it is just a matter of pushing it into the plug until you hear a click. Like the P1 connector, it is keyed to prevent it from being plugged in the wrong way. Also, it has a clip on the connector and a latch on the plug, just like the P1 does. The P4 connector allows more power to be delivered to the motherboard. However, as computers started using more power, this was not enough. The P4 was replaced by another connector and started to disappear from the motherboard. This motherboard is not that old, so notice that it has a P4 plug at the top right of the motherboard. Just as before, it is a simple matter to plug the P4 connector into the plug. Notice, however, on this motherboard, there is an 8-pin plug next to the P4. This is the next connector I will look at. In order to increase power to the motherboard, an 8-pin connector was created. The official name for this connector is EPS12V. The connector is essentially like two P4 connectors. However, the keying is a little different. Once again, providing 12 volts of power like the P4 connector does, you may be expecting this connector to have a name like P5. Keep in mind that P4 was never a formal or technical name for the ATX12V connector. EPS stands for Entry-Level Power Supply. EPS power supplies were created as an alternative to ATX power supplies. EPS power supplies provide more power than ATX could, and thus, when created, were aimed at the server market. At that time, desktop computers were not using a lot of power, but servers required more. Thus, having a different power supply made sense. However, as time passed, desktop computers needed more power than an ATX power supply could deliver. To accommodate increased power demands while maintaining compatibility with the ATX standard, the EPS connector simply includes the ATX connector. The EPS connector can be expanded to include more pins, but in the case of the ATX standard, we only use the 8-pin version. If you compare it with the P4, you will notice that essentially it is two P4 connectors together with slightly different keying. It is difficult to see, but if you look at the pin out, it makes it easier to see. Essentially, the left side of the EPS connector is the same as the P4. After this, the keying is the same, that is, always using the square with beveled pins. As we will see later in the video, a beveled pin will go into a square hole. However, the square pin will not go into a beveled hole. The EPS connector is designed so more pins can be added to the right side. However, the left side is keyed, preventing the connector being used in the wrong plug. Since the P4 connector is still being used on motherboards, most EPS connectors can be split into two. Power supply manufacturers do this for backward compatibility, and some new motherboards use both the P4 and EPS connectors on the same motherboard. To plug in the EPS connector, like the other power connectors, it is just a matter of pushing it in the plug until it clicks into place. On older power supplies, there will probably be a dedicated 4-pin connector. In the case of the newer power supplies, you will need to split the EPS connector into two in order to plug it into the motherboard. Once it's split, as before, it is just a matter of plugging it in. You will notice that either of the split connectors will plug into the 4-pin plug. Although the keying is different for the connectors, the beveled pins are designed to fit into the square pins. Thus, either of the split connectors can be used. Although most power supplies should have an EPS plug that can be split, if it does not, you are still able to plug in the connector and have the remaining 4 pins hang out. If you only have a 4-pin connector and your motherboard has an EPS plug, you can try plugging the 4-pin connector into the 8-pin plug, although this is not recommended. You will notice the 4-pin connector will only go into one side of the 8-pin plug. If, however, I use the split connector from the EPS connector, you will notice that it will plug into the right, middle, and left side. The EPS connector was originally designed to allow different numbers of pins, so this is why it can be plugged in like this. I don't recommend plugging it in this way. On some motherboards, the computer might boot with just a 4-pin connection. However, this setup is not advisable. If the computer demands more power than what the 4-pin connector can supply, it might unexpectedly shut down or crash. Additionally, with fewer pins, the connector might experience a higher current draw. Therefore, even if it seems functional, this configuration is not recommended. This covers the basics of power for the motherboard. But as technology improved, additional processing started to be moved to expansion cards, which increased the amount of power they required. In particular, graphics cards started to use a lot more power. In order to power these expansion cards, another power cable was required. To provide additional power for expansion cards, a PCIe connector was added to the power supply. Like the P4 and EPS connectors, the PCIe connector provides 12 volts of power and comes in two different types, the 6-pin and 8-pin versions. As before, the connectors are keyed to prevent them being plugged in incorrectly. The 6-pin version may have a pin missing. Although this pin is not required, it may still be connected. So don't be concerned if the pin is missing or is present. In the case of the 8-pin version, the missing pins in the connector provide additional power. In order for the expansion card to determine if a 6-pin or 8-pin connector has been plugged in, certain pins called sense pins will detect which plug it is. The expansion card can then detect how much power it can draw from the cable. 75 watts in the case of the 6-pin, and 150 watts in the case of the 8-pin. Thus, it is possible to plug a 6-pin connector into an 8-pin plug. The expansion card should detect which has been plugged in, but don't expect it to work. If the manufacturer has put in an 8-pin plug on the expansion card, it is most likely the expansion card needs the extra power to operate and won't work with a 6-pin connector. For compatibility, 8-pin connectors can generally be split to form a 6-pin connector. This means that power supply manufacturers don't have to provide both 6 and 8-pin plugs, but sometimes you will find they do. Let's have a look at how to use the PCIe connector. For this demonstration, I will be plugging in the two PCIe power connections into a video graphics card. In the case of this graphics card, it has both 6 and 8-pin plugs. In a lot of cases, your power supply will have two PCI connectors on the same cable. Using the same cable on the same graphics card means all the power for that graphics card will go through the same cable. For low-powered graphics cards, this won't be a problem. If, however, you are using a high-power graphics card, it is recommended that you use a second PCIe cable to provide additional power. Opinions can vary depending on who you ask when you need to use two cables, but let me put it in a different way. If your graphics card is using maximum power, that means 150 watts of power going through each plug. If you are using one cable, that is 300 watts going through the one cable. That is a lot for one cable. So, if you are planning on doing this, I hope you purchase a good quality power supply with quality cables. Otherwise, if you are not sure, use two cables. The next step is to plug the cable in. For the 8-pin connector, make sure all the pins are together and plug it into the graphics card. The process is the same as for the power cables. Simply push it in until you hear a click. The process is the same for the 6-pin connector. Simply push it into the plug until you hear a click. The next connection I will look at is not a standard connector, but I will have a look at it in case you come across it. With some NVIDIA cards, you may come across the NVIDIA power connector. There are two different types of connectors, 12-pin and 16-pin versions. The 16-pin should go into a 12-pin plug, assuming nothing is blocking it. If you plug a 12-pin into the 16-pin, the graphic card will detect it is not the right connector and not start up. The difference between the two is the 16-pin connector has 4 sense pins. More on that in a moment. For the NVIDIA connector, make sure that you insert it all the way in. While uncommon, early high-powered NVIDIA cards using the 12-pin connector could experience the connector melting if it was not fully inserted. When the connector isn't fully inserted, it diminishes the contact surface area the electricity can flow over. The reduced contact area leads to a concentration of electrical flow, causing an increase in heat. To attempt to fix this problem, the 4 sense pins were added. These are designed to make sure the cable is inserted all the way in. If the sense pins do not connect, the graphics card won't work. New video cards, if they use the NVIDIA connector, should have the 16-pin connector. If you have an old video card that uses the 12-pin version, make sure it is plugged in all the way and you should not have the problem where the connector starts melting due to heat. You will only come across the NVIDIA connector on high-end NVIDIA cards. To power devices inside the computer, the oldest connection type is the Molex connector. In the old days, this was the primary connection for powering hard disks, optical drives, and fans. Nowadays, if it is used at all, it may be used for peripheral devices. The Molex connector has been slowly disappearing, and you may find that some power supplies no longer include it. The Molex connector has 5 and 12 volt options. However, it does not include 3.3 volts. 3.3 volts was included with the next power connector that I will look at for the emerging technologies, but in reality, it did not get used by many. There is also a smaller version of the Molex connector used primarily for the floppy disk drive. This is called the Mini Molex or Berg connector. Floppy disk drives are long obsolete. This connector is even less commonly used than the Molex connector. You may find that your power supply does not include this connector. Molex connectors are pretty simple to install. The connection can only be put in one way, so the main thing to do is make sure it is the correct orientation. It does take a little force to get the connector to go in, so if you are finding that it is not going in, you probably have it orientated the wrong way. The Mini Molex connector is installed the same way. It is keyed so it will only go in the one way. It is possible, using a lot of force, to get it to go in the wrong way. If you do this, you will most likely damage the device, so ensure that you put it in the correct way. The SATA connector replaces the old Molex connector. It uses an L shape to prevent it being put in the incorrect way. The SATA connector also adds a 3.3 voltage option. 3.3 volts does not get used by many devices. You will more likely find it used in enterprise storage devices rather than those designed for general use. SATA added hot swapping. It does this by staggering the pins in the connector. By staggering the pins, the outer ones connect first, preventing the initial connection sending a power surge to the device. Essentially, since the outer pins connect first, any power surges in the connector are drawn away before the inner pins connect. The data connector for SATA is similar to the power connector, just not as wide. It uses the same L shape to prevent it being put in incorrectly. There have been 3 different versions of SATA released. The last version, version 3, was released in 2008. Therefore, most motherboards you encounter with SATA are probably using version 3, given how long it has been available. The SATA connector supports one bidirectional data lane. With SATA 3, this gives a maximum speed of 600 megabytes per second. There has never been another version of SATA. This is due to there being engineering problems trying to increase the speed while keeping it compatible with older versions. The connector does not support any additional lanes, so it looks like we will be stuck with SATA 3. For modern solid-state drives, 600 megabytes per second is not enough. Therefore, SATA is not used for newer solid-state devices. However, as hard disks are still not that fast, SATA is still used with them. For this reason, SATA is unlikely to disappear from motherboards anytime soon, but you won't be using it for your fast storage devices. To use the SATA data connector, first locate the SATA ports on your motherboard. Then plug in the SATA cable. It is keyed in an L shape, so you need to make sure that you have it up the right way. Some SATA cables feature a clip that securely locks the connector in place. You can see this SATA cable has a metal clip at the top that locks the connector when it is plugged in. To unplug, push down on the clip and pull out the cable. If you don't unlock the cable before removing the cable, you risk damaging the SATA port. On your motherboard, the SATA ports may be together, or in this example, there is one SATA port positioned away from the other 3 to make a total of 4. So don't assume the SATA ports will always be in the same location. To plug in your storage device, the same process applies. Plug the SATA cable into the storage device, making sure it is the correct way up. To plug in the SATA power cable, the process is the same. Plug the L-shaped connector into the storage device, making sure it is the correct way up. There is not too much to know about SATA. If you have trouble plugging in the cable, you probably have it the wrong way around. If your power supply does not have the required connectors or you need more, you can use an adapter. For example, you can use a splitter to split an existing power connector into 2. There are converters that will convert one type of connector to another. You can also get angular connectors. These connectors will be useful if you want to improve your cable management. Your power supply may not have an NVIDIA power connector, as it is relatively new compared with the others. When this occurs, you can use your existing connectors to power an NVIDIA connector. Keep in mind that if you use an adapter, be careful not to overload the PSU. This is particularly important for an NVIDIA connector since it draws a lot of power. Your power supply is designed to output a maximum amount of power. When you start adding splitters, you can potentially draw more power from the power supply than it was designed to output. Higher current can increase heat and cause overloads. Modern power supplies, when overloaded, will cause the power supply to switch itself off without warning. The power supply will generally use a resettable fuse, so after a short time period it can be switched on again. Make sure that your PSU supports any increased power drain when you start using splitters and adapters. If you are using SATA or Molex adapters or vice versa, keep in mind that Molex doesn't include 3.3 volts. Most devices don't use this voltage, so it is generally not a problem. but keep it in mind in case you come across a device that does use 3.3 volts. The next connector I will look at is the M.2 connector. The first formal name was Next Generation Form Factor. This is difficult to say, so in 2013 it was renamed to M.2. It is essentially a small printed circuit board, or PCB, designed to be a small expansion card. It replaces older standards such as mSATA. It is designed from the ground up to take advantage of the space on the PCB while minimizing the size. It is possible to use both sides of the PCB, but it is rare for an M.2 PCB to do this. Since it is designed as effectively an expansion card, it can have other uses beyond just for storage. For example, it is commonly used to add Wi-Fi and Bluetooth to a computer. It can also add adapters or other devices, like adding a U.2 connection or additional SATA ports. Since it is essentially an expansion card, the manufacturer is free to come up with some very creative uses for it. The main uses you will see for it will be storage and wireless. The edge connector for M.2 has 75 positions, of which a maximum of 67 pins can be connected at once. This is done to determine which capabilities are available to the M.2 and also prevent the device being installed in a connection that it was not designed to run in. Let's have a look at how this is achieved. An M.2 connection has 75 pin positions. However, there will always be some pins missing, which is referred to as a notch. Where the notch is located is referred to as a key. This key will determine what connection the M.2 will be able to plug into. M.2 uses 12 distinct notch locations, labeled A key through M key. At the time of the making of this video, only 4 of these keys are currently in use. Different features are available depending on which key is being used. You will find on the market that most M.2 devices that are A key will also be E key. It is not uncommon for M.2 boards to have 2 notches. This increases the number of devices the M.2 board can be used in, and thus the number of potential sales for the manufacturer. Since it reduces the pin count, it does reduce the amount of data that can be transferred. Thus, 2 notches are only found on slower devices. A key supports PCI Express, USB, I2C, and DisplayPort. I2C is a communication bus invented to connect to lower speed peripherals and processors. Thus, when you look at an M.2 device, looking at the keying will give you an idea what it might be able to do. To utilize additional features, the M.2 board may need specific connectors. For example, the Wi-Fi M.2 board will have connector points for the wireless antennas. You can see why that even though there are a lot of features in the M.2 specification, only some get used as a lot of others are not really practical to use. The next commonly used key is B key. B key supports a lot of different protocols, including audio-based ones. Given the challenges of attaching connectors to M.2, it is unlikely we'll ever see an M.2 based sound card. Most B key devices on the market will also be M key. This means that they can be put into a B key or M key connection. More on that later in the video. Notice that PCI Express is also supported. Thus, B key can support PCI Express or SATA. I will look more into what this means later in the video. E key supports a lot of the same protocols as A key, but also supports additional minor protocols that don't get used that much. So I have not listed them. You can see, with an overlap of protocols, that a lot of M.2 devices will be A and E key. Having an M.2 device that has 2 different keys means that it can be used in any motherboard or device that uses A or E keys. More supported devices potentially means more sales. Thus, you can understand why manufacturers do this. Lastly, there is M key. M key devices are generally only keyed as such. You'll notice that M key supports 4 PCI Express lanes. When the connector has multiple notches, you reduce the number of pins the connector can use. If an M-key device had more notches, this would reduce the number of pins and thus the number of PCI Express lanes that could be supported. M-key devices are generally used for high-performance devices, so you don't want to reduce the number of PCI Express lanes going to such a device. You will also notice the M-key supports SATA, so we can see there's a lot of overlap between protocols using different keying. The reason why M.2 devices with multiple notches can be used is devices that use different keying will still work as expected. As M-key also supports SATA, it is common for there to be an overlap of protocols with different keying. This overlap is why M.2 devices with multiple notches can function in devices with different keying. To gain a clearer understanding, let's look at the protocols associated with M.2. There are two different types of M.2 solid-state storage devices on the market. The first uses Advanced Host Controller Interface, or AHCI, and the SATA protocol to access the data on the flash memory. When SATA 3 was released in 2009 with a speed of 600 megabytes per second, this was quite fast. However, SATA was originally designed with hard disks in mind, which utilize a drive head. A drive head can only access one part of the hard disk at once and thus is limited to one queue. Although the queue can handle 32 commands at once, flash memory can access data in parallel, unlike a hard disk, and thus having only a single queue created a bottleneck in performance. To address this, the protocol NVM Express, better known as NVMe, was created. NVMe uses PCI Express to communicate with the computer and thus is much faster. NVMe also addresses the queue problem by increasing it to a maximum limit of 64,000. The question is, how do you know which one your M.2 storage device supports? Most, but not all, B plus M key storage will use SATA. In order to determine if your M.2 supports SATA, the label on the M.2 should have SATA printed on it. Otherwise, you can always check the packaging or the manufacturer's website. In the current market of M.2 storage, most B plus M keys will be SATA. However, there are some that use NVMe. On the M.2 label, it should have printed on it NVMe. Otherwise, you can always check the packaging or the manufacturer's website. Since B plus M key has two notches removed, this reduces the number of pins that are available to transfer data. For these reasons, these M.2 devices can only utilize two PCI Express lanes. In order to utilize more lanes, the M.2 device needs to use M key. This increases the number of PCI Express lanes that can be used to 4. As before, somewhere on the label will say NVMe. If you want the best performance, you should consider purchasing M.2 using M key if your motherboard supports it. Using PCI Express version 3.0, NVMe has a maximum speed of around 3.9 gigabytes per second. This gets even higher for PCI Express version 4 and version 5. Thus, there is a lot of room for speed improvements in the future. It is possible for a manufacturer to use an M key only device that utilizes SATA. B plus M key provides greater compatibility, which means it can be used with more devices, which potentially means more sales. Since there's no distinct advantage to using M key for SATA over B plus M key, manufacturers only use B plus M key for M.2 SATA devices. The last consideration you need to take into account before installing an M.2 device is size. There are a number of different defined sizes for M.2, which are referred to as form factors. The sizes are defined by width and length in millimeters. The width and length are combined together to give a single number. This number indicates the size of the M.2 device, for example, 2280. Motherboards will generally support a few different sizes. Nowadays, the most common sizes are 2280 for storage devices and 2230 for wireless devices. However, it is possible to get M.2 devices of different sizes, but they are not very common. Let's now have a close look at how M.2 connections work. Shown here is an adapter which allows an extra M-key storage device to be installed and accessed using PCI Express. It also has a second connector that allows an M.2 B-key storage device to be connected and accessed using a SATA cable. I have used this adapter to explain a few points, as it is easier to see how M.2 works rather than using a motherboard as an example, but I will look at some motherboards shortly. This adapter has two M.2 connectors. When they are side by side like this, it is easy to see the different keying in the connector, which prevents the wrong M.2 device being put into the connector. The B-key connector was generally used on some laptops and other devices, generally the cheaper laptops. Nowadays, you probably won't come across B-key used in a computer, but will find that a lot of adapters will support it. Nowadays, for computers, M-key is the most common connector used for M.2. Since an M-key connector could support SATA and PCI Express, and space on the motherboard is limited, it makes sense to use M-key. I can only assume that adapters generally don't support both SATA and PCI Express due to the extra components required to do so. You will notice the numbers on this adapter to indicate the size of the M.2. 2080 is a very common size for M.2, so you will notice that the mounting nut is put in this position by the manufacturer. In order to use smaller sizes, the nut would need to be moved to a different position, for example, the 2060, 2042, or 2030 positions. I will now have a look at how to install an M.2 solid-state drive. In the case of this computer, there are two M.2 slots. On this motherboard, they are both under a heatsink. As these storage devices get faster and faster, they also get hotter and hotter, thus it is starting to become commonplace for M.2 slots to have heat sinks. In the case of this motherboard, I will use the second M.2 slot. The reason for this is the first M.2 is PCI Express 5, whereas my storage only supports PCI Express 4. The second slot is PCI Express 4, so I will keep the first slot free in case I get storage later that supports PCI Express 5. Your motherboard will determine which slots support what. Have a look at your manual to determine which slot is best depending on what storage you are using. For motherboards with M.2 slots, not all of them may support SATA M2 drives. It is becoming commonplace for high-speed M.2 slots to not support SATA. I will first need to remove the heatsink. To do this, there are two screws on either side that need to be removed. Once the screws are removed, I can remove the heatsink. You will notice the extra holes in the motherboard if you need to use a smaller M.2. In your motherboard box, there will be a set of screws. In the case of this motherboard, if you are using the largest M.2 form factor, the slot supports the screw in the heatsink and therefore doubles as the retaining screw. Before I can put the heatsink back, I first need to remove the protective film from the back of the heatsink. It is important to do this, otherwise it may melt when the M.2 gets hot. To finish installing the M.2, push it in the slot at an angle, push the M.2 down so it is flat, and put the heatsink back and screw it back into place. That's it. You don't need to do anything else. Installing M.2 is pretty simple. I will now have a brief look at the U.2 connector, although there is a good chance you won't come across one. The U.2 connector was designed to support multiple protocols. It supports PCI Express, NVMe, SATA, and SAS. The big advantage with the U.2 connector is it supports hot swapping. The U.2 connector saw some enterprise use and some high-end consumer motherboards had it. However, in the home market, it never really took off. The main reason for this is probably because the home market decided to use the M.2 connector. The M.2 connector does not support hot swapping, but it is very fast. With USB being very fast, if people needed hot swapping, they often go for that instead. We probably won't see the U.2 connector used much except in some rare cases for enterprise use. On your motherboard, there will be a CPU socket. In the case of Intel sockets, they are named LGA, followed by the number of pins in the socket. Before purchasing a CPU or a motherboard, check that the motherboard supports the CPU, including the model number of the CPU. With Intel sockets, motherboards with a particular socket don't support all CPUs of that socket type. This comes down to a number of factors. Different motherboards have different chipsets. The power delivery to the CPU may have changed, and generational differences can cause the CPU not to work with the motherboard. When Intel makes significant changes to a CPU, they release a new generation of it. A new generation of CPU may have significant architectural changes which make it incompatible with older motherboards. Before installing a CPU, make sure it is supported by the motherboard. The manufacturer will provide a list of CPUs that the motherboard supports. AMD CPUs are generally more compatible with motherboards that use that socket. However, this is not always the case, so it is best to check. If there is a big difference between the CPU age and the motherboard, you are more likely to have compatibility problems. The most common AMD sockets in the consumer market are the AM4 and AM5. For your high-performance CPUs, like the Threadripper, the TRX4 socket is used. There is also a newer socket called the STRX4. Although this socket is identical to the previous socket, it is electrically incompatible. Thus, if you get one of these CPUs, make sure you get the correct motherboard for it. For this demonstration, I will install an AMD CPU. Regardless of whether the CPU is Intel or AMD, the process is the same. In later videos, I will go into it in more detail. The motherboard should be shipped with a plastic protective cover to protect the pins in the socket. To start with, I need to push down on the retention lever and open the retention plate. This will expose the pins in the socket. To install the CPU, locate the triangle on the CPU socket. Next, locate the triangle on the CPU. When installing the CPU, these two triangles need to line up. If they don't, the CPU won't go in. You will notice this AMD CPU does not have any pins on the bottom. To increase the number of connections on the CPU, the pins need to be on the motherboard to increase reliability. To install the CPU, lower it into the socket carefully, trying your best to keep it level. Don't use any force. If it is the right way round, it should fall into the socket. To finish the CPU install, pull the retention lever down, lock it in place, and remove the plastic socket cover. Since this video is about motherboard connections, I won't look at attaching the CPU cooler. That I will leave to another video. There have been a lot of different memory modules over the years. For the A+ exam, the ones you need to know are DDR3, DDR4, and DDR5. DDR4 was released in 2014. Thus, the most likely memory modules you will come across will be DDR4 and DDR5. You will notice that the memory modules have a notch removed from them. This prevents the memory module from being put in a slot that does not support it. DDR gets its name from the bus it uses, called double data rate. Double data rate means that data can be sent on the rise and fall of the clock. This effectively doubles the amount of data it can send in the same time period, which explains where it gets its name. Let's have a look at how to install a memory module. To start with, I will look at how to install DDR3. Given that DDR3 was released in 2007 and DDR4 in 2014, there is a good chance you won't come across DDR3 nowadays. However, it is still listed as an exam objective. All the DDR memory modules are similar in design, including the slots they are put into. For this memory module, there are locking clips on either side. Before installing the memory module, they need to be in the unlocked position. Since there is a gap in the connector that is offset from the middle, the memory module will only go in one way. You will notice that when the memory module is put in the wrong way, it will not go in. It is crucial not to force a memory module if it doesn't fit easily. Applying excessive force can damage both the memory module and the connector, especially if it is oriented incorrectly. I will now rotate the memory module around so it is orientated the right way. DDR3 memory modules have a flat-edged connector. Since it is flat, the memory module can be installed by pushing down on each side. When installing the memory module, it needs to be pushed down until the locking clips lock into place. You should hear a click when this happens. In the case of DDR4, the process is very similar. The only difference is that DDR4 has a slightly curved connector. You can see in the middle of the connector it is curved rather than being straight across. This has been done to allow the memory module to be inserted more easily. This becomes more important with later DDR because the number of contact points on the connector increases. As before, make sure the clips are in the unlocked position and place the memory module so the gap in the connector is in line with the block on the memory connector. Since the block is in different places for different revisions of DDR, you won't be able to put an earlier memory module in. Since the connector is curved, push down on both sides with equal pressure to install the memory module. This is the only real difference when installing newer DDR. If you're having trouble getting a memory module to go in, you can rock it back and forth a little bit to loosen it up, but not too much. Unlike the straight connector, you don't want one side to go in before the other. Instead, you want it to go straight down when it is finished. If it won't go in, it is probably in the wrong way, so remove it and check the gap in the memory module is lined up with the block in the memory module slot. In the case of DDR5, the process is the same as above. You will notice that on this motherboard, one side of the memory module is fixed rather than having a clip that can be locked or unlocked. This is done so when large expansion cards like graphic cards are installed, the physical card will be directly above the edge of the memory module. This means that, unless you remove the expansion card, it will be very difficult to unlock the clip. Thus, motherboards, where this can occur, will often have a fixed edge rather than a clip that can be locked and unlocked. As before, it is just a matter of putting the memory module into the slot with the correct orientation. In the case of DDR5, the gap in the memory module is pretty close to the center, so it is harder to tell if it is correctly oriented. In the case of this motherboard, the block in the memory module is very easy to see. I will now push the memory module down on both sides until it clicks into place. Thus, you can see the process of installing memory is the same regardless of which DDR memory modules you are using. Connecting the CPU to the memory module requires at least one memory channel. A memory channel is a communication channel between the CPU and memory. Depending on the CPU and the motherboard, there can be multiple memory channels. The simplest example is single channel. Here, a single channel connects to one or more memory modules. In consumer motherboards, each channel normally connects to a maximum of 2 memory modules. In certain server motherboards, a single channel can connect to more than 2 memory modules. A lot of motherboards on the market are dual channel. This is where there are 2 channels going from the CPU to the memory modules. It is pretty common for a motherboard to have 4 memory slots, with each single memory channel going to 2 of the slots. On high-end motherboards, you may have triple channel. This is where 3 channels go to the memory modules, or you may even have quad channel, where there are 4 channels. When installing memory modules, which slot you install the memory module in determines which channel it will use. In some cases, the computer will not start up unless a memory module is installed in a certain memory slot. Your choice of slot also determines how many channels are used. To understand better how memory channels work, I will consider an example for dual channel. If you are using triple or quad channel, the same process applies. This information applies to most memory controllers. However, it is possible that some memory controllers may be able to handle memory modules of different speeds without dropping the clock speed to that of the lowest memory module in certain circumstances. Sometimes you just need to give it a go and see what happens and check if the system is stable. When installing memory modules, usually the second memory slot from the CPU should be installed first. Although there is no guarantee this will always be the case, the vast majority of modern motherboards follow this convention. This will connect the first memory channel. The channel provides a 64-bit bus for transferring data to and from the CPU. I will now install a second memory module. When installing the second memory module, this should be connected to the second channel. This means that there are two 64-bit buses that can be used to transfer data to the CPU. So now, 128 bits can be transferred at once. Usually, the second channel will be the memory module furthest from the CPU. You can see that for best performance, make sure both channels are used. In the real world, although using dual channel makes things faster, in reality, only certain memory-intensive applications will benefit from any noticeable difference. I will now install the next memory module. This memory module will also use the first channel. This occurs because the second slot is daisy-chained to the first slot. Since the first slot is linked to the second and the second directly to the CPU, it is preferable to use the second slot first, as it's the initial slot in the sequence. Some motherboards require the first slot in the daisy chain to be populated. With others, the motherboard will still work regardless of which slot you use. Each channel in the motherboard has two slots daisy-chained together. If different memory modules are used with differing speeds, the speed will drop to that of the slowest. Using different memory modules may cause compatibility problems, so it is recommended to use identical ones. This includes memory modules on the same channel and when using dual channel. Dual channel memory utilizes interleaved access, where contiguous memory addresses are distributed across both memory modules, optimizing bandwidth by allowing simultaneous access to both modules. Thus, you can see that installing just one slow memory module can affect all the other memory modules, as they will need to slow down to the speed of the slowest. I will now install the last memory module. This memory slot is chained to the second channel. If you are using triple or quad channels, the process is the same. Consumer motherboards typically feature 2 slots per channel. However, server-grade motherboards with a large number of memory slots might chain more than 2 slots to a single channel. Thus, it's important not to assume that memory channels will always consist of just 2 slots. Additionally, some motherboards with only 2 memory slots may support dual-channel operation, others might not. Check the specifications of the motherboard to find out for sure. The Peripheral Component Interconnect Express, or PCIe, is a high-speed interface standard for connecting add-on cards like graphic cards and network cards. It can also be used to connect components to the motherboard, for example, the M.2 interface. It uses one or more lanes to transfer data. A lane is a high-speed bidirectional transmission path from the device to the CPU or chip, like the South Bridge. If you consider a single lane going to the CPU, a single lane has an input path and an output path. This allows it to transmit in both directions at the same time. PCIe is serial-based communication that communicates by sending data in packets. It is similar in some respect to how data is sent over a network. Having multiple lanes is similar in concept to having multiple network cards. Data can be transmitted over each lane independently. You could also break up your data into segments and dispatch it across all available lanes simultaneously. Historically, parallel transmission was employed to increase data transfer capacity, but it necessitated synchronization of all data lanes. In contrast, lanes facilitate parallel data transfers by segmenting the data into packets, eliminating the need for synchronization. PCI Express has various lane configurations, including by 1, by 4, by 8, and by 16. The maximum number of physical lanes the slot can support is determined by the size of the slot. The physical slot may support a maximum number of lanes, but for a number of different reasons, there may be less lanes connected to the physical slot. It is essential to understand that not all available lanes might be utilized. The actual usage often depends on two primary factors. An expansion card might physically fit into a larger lane slot, but will only use a subset of the available lanes. For example, a PCIe by 4 card can fit into a PCIe by 16 slot, but will only utilize 4 of the 16 available lanes. Even if a slot on the motherboard is physically by 16 in size, the motherboard or CPU might not support all 16 lanes. This can be due to architectural constraints or because other devices are using the available lanes. I have here 4 different expansion cards: a by 1, by 4, by 8, and by 16. I will have a look at how to install them using this motherboard. This motherboard has 3 PCI Express slots, 2 by 16 and 1 by 1. Different motherboards will have different numbers of PCI Express slots. On consumer motherboards, it is pretty common to have only by 16 and by 1 slots. I will first install the by 1 card in the by 1 slot. To install, it is just a matter of pushing it into the slot. When installing expansion cards, handle the expansion card by the edges and don't touch the components. If you have an available by 1 slot, it is advisable to utilize it for by 1 expansion cards like this one, so you are not wasting lanes. The expansion card, however, can also go into a by 16 slot. Even though the connector does not fit the whole slot, PCI Express is designed to work this way. As long as the slot supports the same number or more lanes, the expansion card will go into it. It does, however, mean that of the 16 lanes, 15 lanes are not being used. I will now install the by 4 card. It won't be able to go into the by 1 slot since it is too large. However, it will go into the by 16 slot. As before, if you have a by 4 slot, it is best to use that slot. The by 8 expansion card is the same as before. However, there is a bit of a problem with installing it in this slot. To understand what the problem is, I will have a look at the manual for the motherboard. You will notice that the second PCI Express slot is by 16, but only supports 4 lanes. So, this presents a problem for us since the expansion card supports 8. In some cases, your expansion card may be able to use less lanes and still work, but just at a slower speed. You will need to check the specifications of your expansion card to see if it can work with less lanes. To use this expansion card with 8 lanes, I will need to move it to the by 16 slot. This will mean 8 lanes will be wasted, but sometimes this is the price you need to pay to fully utilize all the lanes in the expansion card. You may be wondering, if the previous slot only supports 4 lanes, why is it a by 16 slot and not a by 4 slot? To understand why this is the case, I will remove this expansion card and install the last remaining card, the by 16, in the by 16 slot. You will notice that when I install the card, there is a clip on the end of the slot to hold the expansion card in place. When you remove the expansion card, you will need to unlock this clip to remove it. If you don't unclip it, you risk damaging the slot on the expansion card. This particular graphics card is by 16, however, it only uses 8 lanes. So we have a by 16 slot that only uses 4 lanes and a by 16 graphics card that uses 8. To understand why it is done this way, we need to move on to the next topic. In the computer setup, you might come across the term PEG. PEG is an anagram for PCI Express Graphics and refers to the primary PCIe by 16 slot on the motherboard. On most motherboards, this is the closest by 16 slot to the CPU. On some rare motherboards, the closest slot to the CPU may have only a small number of lanes. When this occurs, The second PCI Express slot will generally have a lot more lanes and will be the PEG slot. The PEG slot is optimized for graphics cards. This gives better performance and power delivery. Keep in mind, it is still a standard PCI Express x 16 slot, so is compatible with any other expansion card. So what is the difference? Since graphic cards require a lot of power and transfer large amounts of data, the slot is optimized for this. For example, the CPU will prioritize traffic from that slot over other slots. Since graphics cards use a lot of power, the slot can provide a bit more power if needed than the other slots can. Thus, it is best to install your graphics card in the PEG slot. The PEG slot also has one more advantage, which is installing a graphics card in the PEG slot will disable integrated graphics by default. So, this brings us to the reason why graphics cards use x 16 slots. To remain compatible with older PEG slots, graphics cards need to use the x 16 connector. Now you know the reason why graphic cards that support less than 16 lanes still use the x 16 connector. As graphic cards need to use the x 16 connector for backwards compatibility, even if they use less than 16 lanes, the motherboard needs to allow for graphic cards to use it. Thus, any connector that may get used for a graphics card needs to use the x 16 connector even if it does not support 16 lanes. Thus, the PEG slot on the motherboard also needs to use the x 16 connector even if the motherboard is not providing 16 lanes to the physical slot. Motherboards often have multiple x 16 slots even if they don't support all 16 lanes. This is so they can be fitted with graphic cards having x 16 connectors. Graphic cards use x 16 connectors for compatibility with older PEG slots, even if they don't need them all. Other expansion cards do not use the x 16 connector for backwards compatibility, and this is the reason why you only see this done with graphics cards. Now you know why graphics cards use the x 16 connector and motherboards use the x 16 slot even though they don't support 16 lanes. In short, when it comes to graphic cards for compatibility reasons, everything needs to be x 16 in size. The last thing to consider when installing an expansion card is the PCIe version. An expansion card supports up to a particular version number. Usually an expansion card can use a lower version with reduced performance. Expansion cards, such as graphic cards, will often drop to a lower version when the card is idle to reduce power usage. The expansion card, however, may require a minimum version number to operate. Usually this is not a problem since modern motherboards support at least version 3, which was released over 10 years ago. The PEG slot in your motherboard will support the highest version number that motherboard supports. For example, with some motherboards currently on the market, the PEG slot will support version 4 or version 5, but the other slots will support the next version down. When installing expansion cards, several factors come into play. Typically, it's advisable to place the graphics card in the PEG slot and other cards in the remaining slots. If you're adding a high-performance card, such as a high-speed network adapter, ensure it's in a slot that supports its required PCIe version. Otherwise, you may not harness its full potential. Even if a graphics card supports a newer PCIe version, it might not utilize all the available bandwidth. In a basic setup, this may not make much of a difference. For high-performance setup, selecting the right expansion slots for your high-performance cards can make a big difference. Combining multiple graphics cards to boost performance is termed SLI for NVIDIA and Crossfire for AMD. How many graphics cards you can combine together depends on what the graphics cards and motherboards support. There are a lot of graphics cards on the market that do not support combining together. Adding an additional graphics card typically provides a modest performance gain. For instance, pairing two cards might yield a 30 to 40% improvement rather than doubling performance. Incorporating a third card offers diminishing returns. Given these reasons, it is often more cost-effective to invest in a single, higher-performing card instead of a second one or a third one. SLI currently only supports up to 2 graphics cards, whereas Crossfire supports up to 4. If you do opt for a multi-card setup, it is advisable to use identical cards. If there's a mismatch in performance, the faster card will typically adjust down to match the pace of its slower counterpart. Also, you may have compatibility problems if you mismatch graphics cards. To facilitate this multiple GPU setup, a bridge connector may be required. In the old days, this connector was always required. Nowadays, some graphic cards may not require one. For SLI configurations, this connector usually comes with the motherboard, while for Crossfire, it's included with the card. Originally, connectors were provided with motherboards, allowing manufacturers to decide the spacing between slots. For Crossfire, however, compatibility with motherboard slot spacing is assumed, given most motherboards adhere to universal standards. This tradition has persisted primarily due to convention. The next connector I will look at is the Peripheral Component Interconnect, or PCI connector. This was the predecessor to the PCIe connector. Although there were other connectors used, the PCI connector is the legacy connector you are most likely to come across today. Like the PCIe connector, it is just a matter of pushing the expansion card into the PCI slot. The PCI slot is different to the PCIe slot. Thus, you won't be able to plug a PCIe card into a PCI slot by mistake. The PCI connector was introduced in 1992. It was replaced by PCIe in 2003. So you can see, by today's standards, it is a very old connector. Since it is a legacy connector, it is becoming rare on motherboards. If you need this connector on a motherboard, you are most likely going to have to shop around to find one. The alternative is to purchase an adapter. In this example, you can convert a PCIe connector to a PCI connector. In the real world, if you have an old PCI card, it's probably better just to replace it rather than using PCI. In some cases, this may not be possible, so it is always good to know there are some other options. I will next look at the front panel header. This is the header on the motherboard that connects the leads on the computer case to the motherboard. Although the manufacturer is free to design the front panel header any way they want, the front panel header shown is the one that is commonly used. Most of the time, the front panel header is in one place on the motherboard, but I have seen cases where it is divided up and placed in different locations. Usually the motherboard will have printed on it what each pin in the header is for. It can be difficult to read, so if you can't read it, use your mobile phone to take a photo and zoom in. If you have trouble locating the front panel header, have a look at the motherboard manual. The manual will also tell you what each pin does. The front panel header typically offers 2 configurations for connecting the power LED, a 2-pin connector and a 3-pin connector. The 3-pin design enables dual color display on the power LED, such as green for on and orange for standby. Historically, this 3-pin connector was found on older specialized motherboards. However, modern computer cases utilize the 2-pin connector, which only supports a single color. To maintain compatibility with various computer case designs, many motherboards still feature both 2-pin and 3-pin connectors for the power LED. The computer case will generally use an LED, or light-emitting diode. An LED emits light when electricity runs through it, but does not require a lot of power. The downside with using an LED is the connector needs to be connected to the positive and negative terminals. If you get this the wrong way around, the LED will not work. The power button, as its name implies, is linked to the computer's power switch. When pressed, it can turn the computer on or off. While the operating system dictates specific responses to this power press, such as placing the computer into standby mode, the OS can be configured to ignore the button press entirely. Notably, motherboards have a built-in safeguard. Holding down the power button for about 5 seconds will force the computer to switch off independently of the operating system configuration. In the front panel header of a motherboard, there's a section with 4 pins designated for the PC speaker connection. In the earlier days of computing, the PC speaker was responsible for producing all of the computer's audio, encompassing everything from music to sound effects. However, modern computers use sound cards rather than the PC speaker for audio. The PC speakers in modern computers are primarily used for beep codes during system diagnostics. While contemporary PC speakers utilize only 2 of the 4 available pins, the full 4-pin layout remains for backwards compatibility, since some older PC speakers required all 4 pins. The HDD activity light, as the name implies, was originally designated to indicate hard disk activity. However, with the evolution of storage technologies such as optical and solid-state drives, the purpose of this light has expanded. It now indicates activity for any storage device directly connected to the motherboard. This typically excludes external storage devices connected through interfaces like USB. As with the power LED, the positive and negative wires need to be connected correctly, otherwise this LED will not work. 2 pins in the front panel header are dedicated to the reset button. This button is directly connected to the motherboard and initiates a hard reset of the computer. Its function is independent of the operating system, meaning the OS can't modify or override it. It's advisable to use the reset button sparingly, because the operating system isn't given any prior warning. Consequently, any unsaved data will be lost when this button is pressed. The 2 chassis pins, often known as case intrusion detection, are connected to a switch or magnetic sensor on the computer case. When the computer case is closed, this switch or sensor remains in the closed position. Opening the case changes the switch's position, signaling that the computer case has been opened. Depending on the system's configuration, this can prompt a warning message, log an event, sound an alarm, or initiate a shutdown. While most consumer computer cases don't come with this feature built in, it's more prevalent in computers designed for the business market. I will now connect the front panel header to this computer case. In this example, the computer case is quite big, so it is easy to plug the connectors in. If your computer case is smaller, it may be easier to plug in the connectors before you put the motherboard in the computer case. I will first need to locate the connectors in the computer case. Here, the connectors are all together. For your computer case, the connectors may not all be together, and you may need to hunt around to find them all. Notice that there are 2 power LED connectors next to the reset connector. They are separated like this so that they can be put into the 2-pin or the 3-pin connector on the motherboard. I will now start plugging the connectors in. To start with, I will plug the positive power LED connector in the 2-pin power connector of the header. I could also have used the 3-pin part of the connector, as they are both the same on this motherboard. I will next plug in the negative power LED connector. It is important to make sure you connect this correctly. If you get them around the wrong way, the LED will not work. Next, I will connect the power switch. As it's just a switch, the orientation of the connector isn't crucial. However, LED connectors typically have a specific orientation. Once I determine the orientation of the first one, the other LEDs usually follow the same pattern. Thus, I put the connectors in so they face the same direction. While there's no guarantee this will always be the case, it seems to be the trend most of the time. I will next plug in the HDD LED. Because it is an LED, you need to make sure that it is oriented the correct way. In this example, the connectors are marked with positive and negative as the wires are all black. On other computer cases, the cables are different colors to indicate which are the positive wires. The white wires will be the negative ones. I will next put in the connector for the reset switch. Since it is a switch, the orientation does not matter, but I will face it in the same direction as the others to keep everything consistent. This is the last of the standard computer case connectors. I will next install the PC speaker. The PC speaker nowadays is generally a small speaker connected to 2 wires and a connector. The red wire is the positive wire, and the black wire the negative wire. To install the PC speaker, push the connector into the header, making sure you have the red on the positive pin, which in the diagram is shown as +5 volts. In most cases, these are all the components that you will use. However, there is one more that comes on a lot of motherboards, and that is for chassis or case intrusion detection. This connector is connected using a basic switch, like the one you can purchase individually for the on-off button. Although it is easy to find a switch like this one, the difficulty you will have if you use this approach is mounting it to the computer case. Since most computer cases don't include this connection, if you try and add it, you will need to try and find somewhere on the computer case to attach it. If your computer case has this connection, the switch will be built into it. The switch is designed so it will spring upwards when the case cover has been removed. When the case cover is put back on, the switch will be pushed downwards and released again when the cover is removed. Usually a chassis switch like this one is not found in computers aimed at the home market. You generally find this on the more top-end business computers. To connect the chassis switch, it is just a matter of pushing the connector into the header. Since it is a switch, it does not matter which orientation it is. In order to connect certain connectors to the motherboard will have a number of headers. Headers refers to a physical connector or a set of pins on a device or circuit board that is designed to connect and interface with other components or peripherals. The connectors will have a specific layout, number of pins, and are often keyed. Keyed means that a pin is missing or will have a gap in the connector. Keying prevents the wrong connector being put in the wrong header. The USB 2 headers support USB 1.1 and USB 2.0. If you plug in a USB 1.1 device into the USB 2.0 port, the speed of the port will drop to that of USB 1.1. The USB 2.0 headers are often used to connect to the front USB ports of the computer. In the case of USB 2, you can see that it uses a 10-pin connector with a corner pin missing. The motherboard case often has a cable that plugs into this header. Notice that the corner pin is blocked. This is what is referred to as keying. Different headers will have this blocked pin in different positions to prevent the wrong cable being put in the wrong header. It is just a matter of plugging the cable into the header on the motherboard. Keep in mind that there are other headers with the same number of pins, but they have the blocked pin in a different place. It is easy to accidentally try and plug a cable into the wrong header. For this reason, don't force the connector in. If it is not going in, double check you are putting the cable into the right header and that it is oriented the correct way. Modern motherboards should have at least one USB 3 header. It is important to understand that what speed you get will be determined by what header the root hub is connected to. For USB 3, the speed it supports are 5, 10, and 20 gigabits per second. There have been quite a few different naming conventions used for USB 3 over the years, making it confusing what speed you are using. We seem to be moving towards the standard used by USB 3.2, followed by the generation and number of lanes. It can be hard to remember what speed each one supports, so I remember it like this. If you multiply the generation of lanes by 5, this gives you the speed. So, for generation 1 by 1, this would be 5 times 1 times 1, which is 5. Generation 1 by 2 is 5 times 1 times 2, which is 10. Generation 2 by 1 would be 10 as well. Generation 2 by 2 is 5 times 2 times 2, which is 20. If your motherboard has multiple connectors, they may not all support the same speed. With this naming convention, they all start with USB 3.2, followed by the generation and lanes to determine what speed they operate at. This header will often get used to connect the USB ports at the front of the computer case. Although it is not an enforced standard, a lot of the time you will find USB 3 will be blue in color and USB 2 will be black. The computer case will have a cable that connects the ports using a 19-pin connector to the motherboard. Like the USB 2 cable, this cable is plugged into the motherboard. The cable is keyed as before, so don't force it if it does not go in right away. The 19 pins have USB 3 and USB 2 wires. Thus, if you plug a USB 2 device into a USB 3 port, it will still work. There is one limitation to this header that I will look into next. The Type-C header has an extra pin that the USB 3 header does not. This allows it to support cable reversing. This is where you can flip the cable and plug it in the opposite way, and it will still operate. In order to do this, the extra pin is used to detect which orientation the cable is plugged in and makes the necessary changes to support that orientation. The Type-C header and the cable are keyed as with the other connectors. Don't assume that just because the cable is reversible, it is not keyed. The keying is very subtle and can be difficult to see. Like the previous cable, it is just a matter of pushing the cable into the header. To start with, I will try and put the cable in the incorrect way. You will notice that with light force it won't go in, but when I reverse the cable, it goes in easily. Since it is so easy to put this cable in the incorrect way, don't ever force it in. If it is not going in, flip it around and try the other way. If you wish to change your existing USB 3 headers into Type-C headers, it is a simple matter to install an adapter. Since the extra pin is required only to determine cable orientation, this adapter detects this and makes the required changes as needed. The USB 3 header does not know the difference. At the time this video was made, USB 4 had been released. However, there were very few motherboards that had started to use it. USB 4 uses the Type-C connector. Thus, it is probable that in the future we will start to see Type-C USB 4 connectors on the motherboard. Until we start seeing it implemented, we can only speculate what is going to happen. To connect fans to the motherboard, there are two different headers. The 3-pin header is the older type and the 4-pin header is the newer one. Modern motherboards are unlikely to use 3-pin headers. Generally, the 4-pin headers on the motherboard support 4 or 3-pin fans. With a 3-pin header, fan speed is controlled by voltage. The voltage can be increased or reduced to change the speed. The third wire monitors how fast the fan is spinning. Changing the fan speed like this is less responsive and precise than using a 4-pin header. The 4-pin header provides an additional wire that adds speed control. Since the extra wire is used for speed control, the voltage can remain constant. These fans may also be called pulse width modulation, or PWM. If you see PWM on the packaging, you know it is a 4-pin fan. These fans are good to use if they have LED lights. Having the voltage constant will mean the LEDs will remain the same brightness. Otherwise, they would change their brightness depending on how fast the fan is spinning. There are, however, 4-pin fans which change the brightness depending on how fast the fan is spinning. Using 4 pins gives better control of the fan. Thus, I personally think it is best to use this type. Modern computers will increase the speed of the fans when components inside the computer start getting hotter. On the motherboard, the fan headers will be labeled according to their function. The CPU headers will be labeled CPU, and there may be more than one. On most motherboards, it does not matter which CPU header you use as long as you use one of them. You should have some headers called sysfan or something similar. Fans that are connected to the case and provide either intake or exhaust functions should be connected to these headers. You may also have a header called AIO. AIO stands for all-in-one, which essentially means an all-in-one cooling solution. Generally, this will be used by a water cooler, hence the reason this motherboard has the word pump after AIO. The reason it is used by the water cooler is this header is required to provide constant voltage. The header can provide more power than other headers do. An all-in-one solution, such as a water cooler, requires more power than a fan. Although there are some cooling solutions that use the AIO header, these are specialized or customized solutions, so generally only water coolers will use this header. Since the header provides constant voltage, don't use these for fans. The header is designed to be used with all-in-one solutions that essentially manage themselves. For the other headers, fan speeds are controlled by the motherboard rather than being controlled by the cooling solution. When connecting up fans, make sure that you use the right header. Using the incorrect header can cause incorrect fan warnings and fan control. For example, if the CPU is connected to a system fan header, the computer will think that a case fan is connected to that header. Thus, it will start giving you warnings that the CPU fan has stopped since it is not connected. I will have a look at how to install a 3-pin and a 4-pin fan. You will notice the connector has a protrusion on it, preventing it being put in the wrong way. To connect the fan, it is just a matter of pushing the connector into the header, making sure it is facing the right direction. You will notice the extra pin in the header is simply not connected. A 3-pin header provides power and monitors the speed of the fan. I will next plug in the 4-pin connector. You will see it looks the same, just a little wider to accommodate the extra pin. As before, it is just a matter of pushing the connector into the header, making sure it is facing the correct way. You want to make sure when you install extra fans, you use the right headers. In this case, they are both plugged into sysfan, so they are case fans. Although the 4-pin fans are better, I would still use a 3-pin fan over having no fan at all. I will now have a look at how to install a Molex fan using the older Molex connector. It is just a matter of plugging a Molex connector in. These fans are generally the cheapest fans you can get, but have no speed control. Modern computers will speed up and slow the fans down depending on the load and the heat of the computer. When the computer is not under load, this saves power and the computer will run quieter. I will now have a look at an all-in-one or AIO. Although not a requirement, an AIO will generally be a water-based cooler. These can use a 3-pin connector, but can also use a 4-pin connector. Again, it is just a matter of plugging the connector into the correct header on the motherboard. The water coolers that use a 4-pin connector allow the motherboard to have some control over it. Although the water cooler mostly manages itself, some will allow the motherboard to have some control. This is generally done to make it quieter when the computer is idle. Although under load, the cooler is going to have to work harder to keep the computer cool, and thus it is going to get louder. If its ability to cool is reduced, the computer will use other thermal methods to reduce the heat, which can result in reduced performance. If this occurs, it effectively defeats the purpose of having a water cooler in the first place. Thus, the water cooler may not be controllable, or in some cases, the manufacturer will provide additional software to control it. Many motherboards come with integrated graphics. That is, graphics are supported by the computer without a graphics card having to be installed. Nowadays, this is generally done by having a CPU. Thus, the motherboard needs to support graphics and have a CPU that also supports graphics. There are many different connectors that can be used to connect video to the computer. The Type-C connector is starting to become a more commonly used type. If the connector is a Thunderbolt connection, it will support video. If it is USB, it may or may not support graphics. In most cases, a Type-C USB connection won't support graphics unless it has a graphics adapter connected to it. As the Type-C connector becomes more popular, this will start to change. One of the common graphics ports you will find with a computer is DisplayPort. There have been a number of different revisions to DisplayPort as well as other standards. You will find that the higher the standard, the more features and higher resolutions supported. However, even if the features are slightly different to each other, the standards are all pretty similar for the end user. That is, they produce video at a particular resolution. DisplayPort is popular in computers and its features are designed with computers in mind. It also supports daisy chaining, that is, having multiple monitors connected together in a chain link fashion. Type-C also supports daisy chaining. HDMI was designed with home entertainment in mind. It does not support daisy chaining, but does support audio return channel. Audio return channel allows audio to be transferred in the opposite direction to the video. This is useful, for example, when using audio equipment with devices like a video USB stick. This will require the audio to travel in the opposite direction from the TV to reach the audio equipment. When it comes to computers, in my opinion, HDMI and DisplayPort typically yield comparable results, except in specific scenarios that necessitate features like an audio return channel or daisy chaining. DVI is an old connection type which is nowadays considered to be obsolete. It was the first connection to support digital signals. It also supports analog signals, but when using analog, you won't be able to use higher resolutions. The last connection you may come across is VGA. This standard is obsolete and supports analog signals only. DVI and VGA are becoming very rare now and probably won't be used on new electronic equipment. Since it is obsolete, if you don't need to use it, I would use one of the other options. Although not a connection on the motherboard, which this video is about, I will quickly talk about graphics cables, as this can make a big difference to what results you may get. If I've not said it before, I will say it again. Not all graphics cables are created equal, and you get what you pay for. There have been a number of different revisions of graphics standards, and therefore it can be difficult to understand what a cable supports. A cable that supports a particular standard may not support the same resolutions as a better quality cable. The quality of the cable is a big factor in the maximum resolution that is supported. The speed the cable supports is often a good indication of the quality of that cable. I provided two examples of cables, one DisplayPort and the other HDMI. The DisplayPort cable supports up to 8K at 60 Hz, while the HDMI cable supports 8K but only at a maximum of 30 Hz. You will notice the HDMI cable supports almost half the speed of the DisplayPort, thus it does not support the data needs of 60 Hz. Keep in mind, this is the maximum and it does not support everything at this resolution. For example, the resolution won't support maximum chroma subsampling. Chroma subsampling is a video compression technique that reduces the amount of data that needs to be transferred across the cable. Often brightness is kept and other details like color are reduced. To the end user, it may not be that noticeable, but for professional work like graphical production, you want quality graphics. Thus, I would work out what resolution you want, what other features you want, such as chroma subsampling, to determine which cable you need. If the motherboard is made to a standard such as ATX, it will have an area dedicated to connectors. This is a standardized size, but manufacturers are free to use the area however they wish. This area may be called the I/O area, rear panel, or back panel. If required, the manufacturer of the motherboard will provide an I/O shield. This shield keeps out dust and helps prevent electrical interference getting inside the computer. Thus, it is important to put in the I/O shield when you put a computer together. Since they are customizable, you most likely won't be able to use an I/O shield from another computer since they will most likely be different. In some cases, the I/O shield will be part of the motherboard. When this occurs, there won't be an I/O shield. This seems to be becoming more common on more expensive motherboards, but the cheaper ones are still using an I/O shield. I will now have a look at how to install the I/O shield. The shield will need to be installed before the motherboard. To install it, place the I/O shield in the I/O area and push around the edges to click it into place. The metal can have sharp edges, so be careful not to cut yourself. In this case, the I/O shield won't go in properly. When it does, it should be flush with the computer case. If you have trouble getting the I/O shield to go in, try removing it and start again by inserting a different edge into the I/O area first. Last time I put the top in first. This time I will put the bottom edge in first. As before, push around the I/O shield trying to get it to click into place. If you're having problems getting it to go in or don't want to risk cutting yourself on the metal edges, you can use a screwdriver to push the I/O shield in. Once all the edges of the I/O shield click into place and it is flush with the case, it is done. Note, it can be a little tricky to get it to click into place. I will now have a look at some of the connectors that are found in the I/O area. One of the common connectors found on a computer is for the network. There are a number of standards for network cables. The most popular standard has been Cat5e. Cat stands for category. When a cable is manufactured, if it meets a particular standard, the manufacturer can say it is that category of cable. Higher speeds require better quality cabling. Over the years, there have been many different speeds. Nowadays, the most common standard is 1 gigabit. You may come across the occasional 100 megabit connection on some devices, but it is mostly 1 gigabit for home and general office networking. Historically, the difference in speed went up by a factor of 10. The next speed after 1 gigabit should logically be 10 gigabits. This standard and even higher speeds are used by internet companies, data centers, and server rooms, but not really seen in home networks. The reason for this is the high cost difference between 1 gigabit and 10 gigabits. From an electronics perspective, the increase in cost is much higher than it was with previous standards. For this reason, interim standards of 2.5 gigabits and 5 gigabits were created. These standards cost less and thus were an effort to try and provide faster speeds than 1 gigabit at reasonable cost. They are designed to be interim standards, and thus, when we all start using 10 gigabits, expect to see these standards slowly disappear from the market. All the standards are backward compatible, so your networking equipment all needs to support the highest speed, otherwise it will drop the speed down to that of your networking equipment. The original Cat5e standard was designed to support speeds of 1 gigabit per second. The 2.5 and 5 gigabit standards came after Cat5e was released. Although not designed to run this speed, they have been able to get 2.5 and 5 gigabits to run over it. Cat5e has its limits, thus newer standards of cabling called Cat6 and Cat6a were released. These use the same RJ45 basic design, but the connectors are slightly different, as the connector is wired differently. There is another standard after this called Cat7. However, due to it using a different connector, these are mainly used in data centers. Cat6 and Cat6a cables support speeds of 10 gigabits per second. Cat6a is a better quality cable. However, you will find they cost more than Cat6 ones. For your networking, if you are going above 1 gigabit, I would consider using a Cat6 cable. Although technically supported using Cat5e, the limits of the cable are being pushed pretty hard. If the quality of cable is poor or slightly damaged, this will affect the speeds you will get through the cable. Getting Cat6 future-proofs yourself, so I would recommend looking at purchasing Cat6 cables if your budget allows. To connect a network cable, it is just a matter of pushing the cable into the connector until you hear it click into place. This cable has a latch, so to unplug the cable, you need to push down on the latch. You will generally find that if you push down on the latch when inserting the cable, it will go in easily. Wi-Fi connections are generally pretty easy to install. If your motherboard has Wi-Fi connections on it, it is a simple matter of screwing the antennas in. You want to screw the antennas in so they are finger tight. Not too tight, but if a connection is loose, it won't work as well. If there is more than one antenna, which is quite common, you want to screw the second one in as well. Newer Wi-Fi standards have the ability to transmit on multiple frequencies at the same time. While it is technically possible for a single antenna to transmit on multiple frequencies at the same time, interference and other considerations often lead to the use of multiple antennas being used. To put it simply, if you don't put all the antennas on, depending on which antenna the Wi-Fi chooses to use, you could significantly reduce the quality of the signal. Your motherboard might feature an M.2 Wi-Fi slot. Installing a Wi-Fi module in this slot equips the motherboard with wireless capabilities. However, this could deactivate other functions, such as a SATA connection. Let's have a look at how to install it. In this case, I have already installed the Wi-Fi antennas. You can install these first. However, generally it is easiest, for reasons I will demonstrate shortly, why you may want to install them afterwards. For this installation, there is the M.2 board, a screw, and a small retention plate to hold the antennas in place. You can see the back of the Wi-Fi connectors. These run wires to a micro connector. The technical name for these connectors is MHF4. Don't worry about remembering that name. No one will ever ask you. They are specifically designed for Wi-Fi signal transmission. Since I put the antennas in the case already, I have limited wire reach. To attach the antennas, I will place the Wi-Fi M.2 board on the power supply to give me a flat surface. You can see the two circular antenna points that I need to connect the cables to. To connect, Place the circular connector on the board and press down with a screwdriver. These connectors can pop loose very easily, so this is one reason you may want to consider installing the antennas afterwards. Connect the second connector the same way as the first, so I won't worry about showing how to do that now. I will next need to plug the M.2 Wi-Fi card into the motherboard. Since the card is keyed, it needs to be in a Wi-Fi slot, not a storage slot. Not all motherboards will have this. To install, place the card in at an angle. Once the card is in place, push the card down and screw in the retention plate. This will hold the cables in place. This part can be tricky as the cables will sometimes pop out of the connector. Thus, you may want to partially screw in the retention plate and turn it out of the way, then connect the antennas, turn it back, and finish screwing it in. They can be fiddly to get in place, so do whatever works for you. The direction you point the antennas changes depending on which antennas you use, so let's have a closer look. The antenna dictates the radiation pattern of the signal. While some Wi-Fi systems permit power adjustments, there are regulatory limits on the transmission power based on one's geographical location. Once you hit this threshold, you can't boost the power any further. However, you can modify the way the signal is transmitted. Let's have a look at some examples, and it will make more sense. The most common antenna you'll encounter is the omnidirectional antenna. This antenna broadcasts a 360-degree sphere. Given its ability to transmit in all directions, it's especially useful in multi-story buildings. These antennas are typically short in height, and since they transmit in all directions, there's no need to position them facing a specific direction. The next type you'll encounter is the high-gain variation of the omnidirectional antenna. These are often found in premium routers. Unlike standard omnidirectional antennas, they transmit primarily horizontally. This makes them especially useful in single-level buildings. Essentially, the antenna has a fixed power limit, so it concentrates the transmission horizontally. As a result, the signal should extend further from the access point to cover long horizontal areas, but won't go as far vertically. Unlike standard omnidirectional antennas, when the Wi-Fi is aligned horizontally with the floor, the antennas need to remain vertical. If they aren't kept like this, the signal will be broadcasted at an angle, diminishing its horizontal reach. The final antenna type you might encounter is the directional antenna. These antennas concentrate the signal, channeling it as close to beam-like as possible. They are primarily used for point-to-point transmissions. These antennas are still considered to be high-gain antennas. When the signal is focused rather than being 360 degrees, it is high gain. The more focused, the higher the gain. Thus, if you are comparing two directional antennas, the one with the high gain will have a more focused signal. For optimal performance, it's essential to ensure that the antennas on both ends are directly aligned with each other. If one antenna is even slightly misaligned, it will reduce the signal. If it is too far out of alignment, it won't work at all. Universal Serial Bus, commonly known as USB, allows devices to be connected to the computer. Modern computers typically feature USB ports in the I/O area. While USB ports are often color-coded, it is not an official guideline but rather a widely accepted convention. The black ports are typically USB 2.0. These will be backward compatible with USB 1.1 devices, since USB 1.1 is still used for slower devices such as keyboards and mice. Blue ports typically represent USB 3.0 ports, and cables are often color-coded. USB 3.1 ports sometimes are color-coded in a lighter shade of blue. However, this isn't a strict rule. Some motherboards might have multiple USB 3 ports of the same color, but support varying speeds. Distinct colors generally indicate different speed capabilities, so if you see this, it is generally an indication that ports run at different speeds. You may also have ports of other colors, for example, red. These USB ports work just like data ports. However, they also have additional power features. For example, the port may provide more amps than a regular port. This means that devices connected to them can draw power if they support it. This is often used to charge mobile devices faster. These ports may also provide power when the computer is off. Therefore, a device can continue to charge while the computer is off. If you see one of these ports, check the documentation for the computer to determine what additional features it supports. If you have a Type-C connection, these connections support previous USB standards and speeds. Type-C, however, is required for speeds of 20 gigabits per second or greater. Thus, for USB 4, you will require a Type-C connection, and it won't work with the previous types. Type-C also allows the cable to be connected in either orientation, unlike the others which must be put in the correct way. Most motherboards don't have many Type-C connections, if any at all. However, since they are the connection required for high speeds and for USB 4, we will most likely start to see them become a lot more common. Your computer case typically features an HD audio connector used for an audio connection, usually audio jacks. Most computer cases have these ports on the front, which is why they are termed front panel connectors. However, they can technically be located anywhere on the case. The connector is commonly used for headphones and microphones only. However, advanced features like surround sound, Dolby, and DTS are also supported. To install the connector is quite simple. First, locate the connector in your computer case. The connector may have HD audio printed on it. It will always be a pin connector with one of the pins blocked so it does not get put in the wrong header. The USB connector is also 10-pin, but keyed differently. Thus, if you find the connector is not going in, you may have the USB connector by mistake. Like other connectors, simply push it into the header. If you find that it is not going in, you may have the connector orientated incorrectly, you are using the wrong connector, or the wrong header. Don't ever force it, as it may damage something if you do. Sound jacks primarily provide analog audio through a 3.5mm or 1/8 inch connectors. While in some contexts they are viewed as legacy technology, they remain in widespread use and continue to receive support in many devices. Although there are better digital solutions available nowadays, my opinion is that since audio jacks were so successful in the marketplace and have so much support, this is the reason we still see them included. I don't think that will change anytime soon, but one day the sound jack will be considered obsolete and will start disappearing from computers. A notable feature of modern sound jacks is the auto-detect capability, which can automatically adjust the jack's function based on the type of device that is plugged in, provided the hardware supports this feature. For example, if you plug a microphone into an audio out jack, the audio jack can change to a microphone jack, assuming auto-detect is supported. You can see here an example of the colors that are typically used for audio jacks and their function. Audio jacks typically come in color-coded formats. While there is no official standard, manufacturers often gravitate towards similar color schemes. For surround sound, these colors are more likely to vary. Usually, connectors in the I/O area adhere to this color convention, but the audio plugs on the front of the computer are more likely to deviate. There is not much to know about sound jacks, you just plug them in. You won't damage anything if you plug in the wrong jack. Often the operating system will have software that helps you identify what each jack does. The SPDIF connection, a creation of Sony and Philips, hence the name, is a digital-based solution that supports standard audio and surround sound. In contemporary computers, if there's an SPDIF connection in the I/O area, it is typically a fiber connection, referred to as a toslink. The SPDIF and toslink connections are starting to disappear from the market. Originally developed by Toshiba, fiber is not subject to electromagnetic interference. However, it is susceptible to breakage if bent excessively. The limitation of SPDIF is its unidirectional nature, as it only sends data and doesn't receive any. Consequently, the computer cannot obtain feedback from the connected device, including error messages or even the device's connection status. For example, If you connect a Toslink cable to a device that isn't powered on, the computer will continue to send data unaware that the device isn't active. When connecting an SPDIF to another device, ensure that the receiving device supports the standard. While many surround sound systems may be compatible, it's crucial to verify support for specialized audio devices. Since the devices won't send any error data back, if it does not support the standard, it won't play any audio. Devices that support bidirectional communication will often communicate with each other to decide on a common standard that both support. Nowadays, you will find most surround sound systems use Bluetooth rather than a fiber cable. Audio does not have very high data speeds, thus Bluetooth has a high enough bandwidth to support it. Also, it supports bidirectional communication and is easy to set up. On your motherboard, you may also have some SPDIF headers. These don't use fiber, however, like the fiber connection, are unidirectional. These headers are also disappearing from motherboards. In my opinion, due to SPDIF not having bidirectional communication, I would look to another digital audio solution whenever possible. To use the Toslink connection, it is a simple matter of just plugging it in. The connection is keyed, so it will only go in one way. If you find the connection is not going in, pull it out, turn it, and try again. Since the connection is square, you may need to turn it 90 degrees to get it to go in. The PS2 connection is one of the oldest connections for the PCs. In the old days, there used to be two PS2 connections, one for the keyboard and one for the mouse. Nowadays, you are generally lucky if your computer has one PS2 connection. If you do need two, you can always purchase a PS2 splitter to split the connection into two. The PS2 connection is a legacy connection and considered obsolete nowadays. The biggest advancement of the PS2 connection was it supported multiple keys being pressed at once, called N-key rollover. On a well-manufactured PS2 keyboard, you can simultaneously press multiple keys and they will all be registered accurately. USB keyboards support varying levels of simultaneous key presses. This can also change depending on what USB device driver the operating system is using. Multiple key presses are important in gaming, where multiple keys need to be pressed at the same time. Simultaneous key pressing is supported better in USB than it used to, and some USB keyboards boast that they support N-key rollover as well as PS2 does. In my opinion, if simultaneous key presses is important to you, a good USB keyboard should be able to meet your needs. The biggest disadvantage of a PS2 connection is that it does not support plug and play. In order to plug in a mouse or keyboard using PS2, you will need to reboot the computer. To plug in a PS2 connection, it is just a matter of making sure the connection is orientated the right way. It should just click into place. On older computers, the keyboard may only work in the keyboard and the same for the mouse, while in modern computers, you should be able to use either. On your motherboard, you may have a Thunderbolt header. The Thunderbolt header will vary between different manufacturers, thus there is no standard. One manufacturer may even have different Thunderbolt headers, usually for different versions of their Thunderbolt expansion cards. In order to get Thunderbolt to work, you first need to install a Thunderbolt expansion card into the computer. The Thunderbolt card will have a cable that connects the expansion card to the motherboard. Thus, when you purchase a Thunderbolt card, you will need to purchase one that is compatible with the motherboard. Thunderbolt has the ability to daisy chain devices together. For example, you could daisy chain multiple monitors together. Thus, for it to work correctly, there also needs to be a cable that connects the video card to the Thunderbolt card. Usually this cable will be included and is very short. Older versions of Thunderbolt, versions 1 and 2, used the Mini DisplayPort connection, which is a smaller version of the DisplayPort connection. The newer versions, versions 3 and 4, use a Type-C connection. Thunderbolt can be difficult to get going, so before you purchase a motherboard, I would do some research to see if other people have been successful in getting it to work. Light headers provide a connection point on the motherboard for controlling internal PC lighting. There are two main standards and also some proprietary ones. If your device uses a proprietary standard and your motherboard does not have those headers, sometimes you can get additional components such as lighting control boxes that will convert between the regular standard and the proprietary standard. Both standards use a 4-pin header. Although the second standard is keyed, it is still possible to incorrectly connect the standards together. If you do this, you can damage any devices connected to them. The older standard is RGB. All devices connected to this header will display the same color, so changing the color will change everything connected to that header to the same color. This header puts out 12 volts. The next standard is ARGB, or Addressable RGB. All devices connected to this have the color individually controlled. This standard uses 5 volts. Thus, you can understand that having two standards using different voltages, you need to make sure you don't connect them to the wrong header. If you do this, your devices may get damaged. I will now have a look at how to use the two most prevalent light headers you're likely to encounter. On this particular motherboard, the headers are right next to each other. On your motherboard, they may not be. There may also be multiple headers on the motherboard. The ARGB header is on the left and has the missing pin, while the RGB is on the right and has 4 pins. I will start by looking at the RGB connector. I have an LED light strip that I will connect to the header. These are often used for background lighting such as mood lighting. Also, they have become popular with internet streamers. Although you could connect the LED strip directly to your computer, there are also a number of other LED solutions that connect to the computer using other connections like USB. Also, for using external lighting systems to light your room, for example, it may be worth looking around to see what is available. The LED strip has a 4-pin connector on the end. Since the connector is not keyed, it is easy to plug it in incorrectly. The connector should have an arrow on it to indicate where the first pin is. Since the connector is a male connector and the header on the motherboard is also a male connector, I can't use them together, so I will need to use a cable with a female connector on each end to connect the LED strip to the motherboard. Notice that each end of the cable has an arrow to help put the connector in the right way. I will now plug the cable into the header on the motherboard. Your motherboard should have some markings on it to indicate where the first pin is. In this case, the pin is colored white. If you can't work out which pin it is, you will need to look in the manual. It is just a matter of pushing the connector into the header, making sure it is aligned correctly. That is, the arrow on the connector should line up with the marked first pin on the header. I will now connect the LED strip to the cable. I will first connect the cables together so the arrows are not lined up. You can see it is very easy to do this since the cable is not keyed. You want to make sure that when you connect them together, the arrows are pointing towards each other. I will now switch on the computer. Depending on your computer and your computer's setup, the LED lights may come on when the computer starts up or may require the operating system to switch them on. This particular motherboard has an interesting feature when it comes to the LED lights. This motherboard has a switch which turns the LED lights on or off. This is useful if you are trying to perform maintenance on the computer and you don't want the LED light shining in your face while you are working. Once I flick the switch, the LED lights will come on. If you find that your LED lights don't seem to be working, you may have a switch like this one on your motherboard. I will now have a look at the Addressable RGB connection. This has two connectors, the power connector and the LED connector. I have already connected the power connector to this motherboard. You will notice that the LED connector has a blocked pin. This prevents it from being put in the RGB header. It will, of course, go into the ARGB header since there is a pin missing in that header. Many ARGB connectors will have a second connector attached to the first. When I remove the cap from the end, notice that there are 3 pins inside. This connector is used to daisy chain to the next ARGB device. The next device can be connected to the first in a daisy chain manner. It is just a matter of making sure the connector is orientated the correct way. The next device is an ARGB hub. This device connects multiple ARGB devices into the one connection, just as USB hubs do. You may hear devices like these called controllers or splitters. I will next plug the connector from the fan into the ARGB hub. The rest of the connectors I've already connected. These are for the fans on a water cooler and a SATA connector for power. I will now switch the computer on. You will notice that all the fans display the same colors at the same time. They are, however, all individually controllable. You can install software on the computer that will allow you to control which color each fan will display. This is how you connect the RGB and ARGB headers. Before I finish with lighting, there is one last thing I will look at. When using different connectors, the keying on the ARGB will stop the connectors getting mixed up in most cases, but not all. It is important not to mix these cables up because one standard uses 5 volts and the other 12 volts. Mixing them up can potentially cause damage. In this example, I have 2 extension cables. One uses the RGB connector and the other an ARGB connector. The ARGB connector will plug into the ARGB cable as you would expect, but notice that it also plugs into the RGB connector. You can see that it is possible to use an RGB cable to extend ARGB, but I would not recommend you do that. There are extension cables, splitters, and other devices available for both types of connections. These are pretty cheap, so if you need to extend either, I would recommend just buying the right cable. If you start mixing things up, you risk connecting the wrong devices to the cable. These cables will often come with a female-to-male adapter. It is possible to plug one of these adapters into a cable of a different type. You can see this RGB cable with the adapter installed now looks like an ARGB connection. Although it may be tempting to use a spare cable or adapter which is lying around, I would recommend against doing this. Once you start interchanging connections, there is an inadvertent risk of connecting the wrong devices together, which may cause damage. Some high-end motherboards feature a small LED screen. This may be referred to by many names, such as debugging LED display, or postcode display, or code 80. It displays 2 hexadecimal numbers. If your motherboard does not have one of these displays, and if your motherboard supports it, you can use a post card. When your computer is started up, or posting, post standing for Power On Self-Test, different codes will be displayed by the LCD screen. These codes are determined by the manufacturer and thus change between motherboards. If the LCD screen gets stuck on a particular code, this tends to indicate a problem has occurred. Personally, I have not had a lot of luck with debugging codes. They have fixed a problem here and there, but sometimes they will display a number for which you can't find information that tells you what it means. Manufacturers don't always provide this information. Since I/O port 0x80 is traditionally used for postcodes, this is where 80 comes from. In the real world, although they can sometimes be useful, I tend to use other troubleshooting methods first before looking at postcodes. I tend to look at postcodes when other methods fail. On your motherboard, there may be a number of debugging LEDs. These will light up during the post process. In the case of this computer, they will indicate boot, video, memory, and CPU problems. It is normal for the lights to come on when the computer starts up. However, once the computer is booted, the lights should go off. If any of them are still on, this indicates that there is a problem. You can also get add-on cards that add this functionality to the computer. Resetting the BIOS, or clearing the CMOS, reverts all BIOS settings to their factory defaults, erasing custom configurations such as boot order and overclocking adjustments. This action may also reset the system clock and remove BIOS passwords. The process can help resolve boot or stability issues stemming from misconfigurations, but any specific customizations will need to be manually re-entered after the reset. If you switch on your computer and get a black screen, a BIOS reset is one of the things that you can do to try to fix the problem. Modern computers use UEFI rather than BIOS. However, you will often hear it referred to as resetting the BIOS by convention, although technically you would be resetting the UEFI. In different motherboards, the procedure may be slightly different, so best to check your motherboard manual for the exact procedure. If you're using a TPM, this may reset it or cause BitLocker to go into recovery mode. If you are using BitLocker, put BitLocker in suspended mode first. If you're using a TPM, check to see how this will affect it. This is particularly important when the TPM is part of the UEFI and not a separate chip. Nowadays, most motherboards have 2 pins that are used to reset the BIOS, while others require the computer to be switched on in order to reset it. This motherboard has a 2-pin BIOS reset header, which is pretty standard for modern motherboards. To reset it, while the computer is off, I need to short the pins with a jumper. If you lack a jumper, you can use a screwdriver to bridge the pins. However, this method is more challenging, as maintaining a consistent connection between the 2 pins for the necessary duration can be tricky. Once you have bridged the pins for the required time period, remove the jumper. The next step is to switch the computer on. If everything has gone correctly, when the computer starts up, you will generally get a message saying the CMOS has been cleared. When this occurs, it is best to go into the computer setup and configure it. Depending on the computer, you may also need to set the date and time. If you don't do this, it will cause problems later, as some security requires the date and time to be correct, for example, Windows Login. If you are working on an older motherboard, it may have 3 pins rather than 2 pins. If this is the case, the typical procedure is to move the jumper to the alternate position by moving it over. Switch the computer on. You may get an indication it worked or just a black screen. Next, switch the computer off and move the jumper back to the original position. If all worked correctly, as with the 2-pin example, the settings in the BIOS should have been cleared. If your motherboard has one, the TPM header allows for the installation of a Trusted Platform Module, TPM, on the motherboard. This module plays a crucial role in several security functions, such as secure boot, BitLocker encryption, and secure key storage. A lot of modern motherboards have begun integrating the TPM directly within the UEFI, eliminating the need for a separate module. In some cases, because the TPM is included in the UEFI, even expensive motherboards may not include a TPM header. Installation of the TPM module is quite simple. Since it is keyed, make sure it is oriented the correct way and push it into the header. The trick with TPM modules is they are very often specific to certain manufacturers, and in some cases, they're motherboards. You need to make sure the TPM module that you purchase works with your motherboard. There are also 2 different versions of TPM. To run Windows 11, you will require version 2.0. This was released in 2014, so most likely if you purchase a TPM module today, it will be version 2.0, but best to check. In some cases, the TPM header may support a debugging card. It is just a matter of plugging this card into the TPM header. This particular card has an LCD screen to display the post codes, but it also has an easy debug section, which shows some diagnostic lights which may help when troubleshooting. Debug cards like this also require motherboard support. Essentially, the TPM in this example connects to the lower pin count, or LPC, bus. The debugging card uses the same LPC interface and thus can connect to the header. However, it will only work if the motherboard sends debugging information over that bus. Thus, you need the right TPM header and motherboard support. The first computers always came with serial ports. These were used to connect external devices such as mice, scientific instruments, and some printers, just to name a few of its uses. USB was introduced in the late 90s and provided faster data transfer rates, a greater variety of compatible devices, as well as plug-and-play, making it very popular in the marketplace. By the early 2000s, serial started disappearing from computers. The serial port is considered to be a legacy connector. It may still be used by engineers to debug hardware, some old devices, or some specialized equipment, but nowadays pretty much everything is USB or uses another kind of connection. I will look at how to connect to the serial header of the motherboard. If your motherboard does not have this header or you don't want to connect it up, you can always use a USB to serial adapter. These are often easier to use and my preferred choice if I need to use serial, as I can simply plug it in when I need it and unplug it when I don't need it. On your motherboard, you may or may not have a serial header. They are not present on all motherboards. The header is keyed. In this case, the top right pin is missing. You will plug the serial bracket into the motherboard. Notice that the connector is not keyed. Thus, it is easy to plug this connector into the wrong header. On this motherboard, the serial header and the USB header are right next to each other, the serial header being towards the bottom and the USB header being towards the top. The keying is different, but because the connector on the bracket is not keyed, notice that I can plug it into the USB header. The serial connector won't work if it is plugged into the wrong header and can potentially damage something. Non-keyed connectors can easily be connected wrongly, as in this case. Some manufacturers use non-keyed connectors to reduce manufacturing costs, or because of a lack of original standards, or to provide as much device compatibility as possible, even with those that do not follow the standard. After all, the manufacturer wants to sell as many as they can at the cheapest cost to them. Although this does not happen a lot with modern computers, as we have good standards nowadays. Keep an eye out for them when older standards are used. I will now unplug it and connect it into the correct header. If you have trouble locating the header on the motherboard, check the motherboard manual. If you come across a non-keyed connector, don't assume that if it goes into the header, it is the right one. I can now plug a serial cable into my serial bracket. You can see why USB serial adapters have become popular, as they are easier to use than a serial header. The serial cable will next need to be plugged into a device. Not all devices will use the older, larger serial connector. In the case of this device, it uses an RJ45 connector rather than a serial connector. It is just a matter of plugging it into the port on the front of the device, usually labeled console. Modern devices should use USB rather than serial. You should only really need to use serial for old or specialized equipment. For example, programmable logic controllers or PLCs used in industrial manufacturing equipment. That concludes this video from IT Free Training on motherboard connections. Quite a long video, and I hope it helped you understand the connections found on your motherboard a lot better. Until the next video from us, I would like to thank you for watching.